Good morning, class. How are you? Yes, I'm very fine. So, we are now studying our number system. So, our topic of discussion today is irrational number. Okay, till rational number we have discussed, we have found how to insert one or more than one rational number between two given numbers. So, now we are going to discuss this irrational number. Okay, what is that irrational number? Which cannot be expressed as a fraction. Okay, see here it is general, which cannot be expressed as a fraction for any integer. They have decimal expansion, but it neither terminate nor recurring, means periodic. Okay, so this is called irrational number. Okay, so now we are going to discuss these numbers here. Suppose here is some definitions. Okay, see 1.5, it's a decimal expansion, but it is a ratio also and it is a rational also. But pi, it still value is being searched, so it is neither terminating nor it is repeating. See, the values are not, because you have learned about that recurring decimals also, so you are knowing that this is not a rational number. Very good. Okay, so pi is not a rational, it is an irrational number, but it is equivalent to 22/7. See, pi is approximately equal to 22/7, which is a rational number. 22/7 is a rational number, but see, pi is not a rational number. It's confusing, no? So this is called mathematics. We have to learn each and every minute details. So understood? See, pi cannot be written in the simple fractions. Okay, there are some more famous irrational numbers. Okay, here is that. See, in this, root 2 is not a rational number, it is an irrational number. That means what? That means all the numbers which are not a perfect square or perfect cube also, they all are irrational. Suppose if I want to write square root cube root of 8. Okay, yes, this is a rational number. See, this is a rational number. But if I write cube root of 16, now it's impossible. That is why this is this one is irrational number. Correct? Very good. So we have very clear concept now for rational and irrational. Okay, now the next are some famous irrational numbers. Here is that list. It is also very important here. One is pi, we have just discussed. One is called Euler's number. See, they have calculated a lots of decimal places without any pattern. So this is the pattern here. See, it is still being continued. So this is a non-terminating, which is not repeating also. So these are the list. One golden ratio is also there. That is are the list of some irrational numbers. Okay, so we can conclude here. Yes, we can conclude that all the square roots, cube roots are irrational if they are not perfect. That square root of 99, see, it's still going on. But the square root of 16, that is equal to 4. Yes, this is a rational number. So likewise, every square root is not an irrational. Some may be rational also. So keep in mind these things. Okay, perfect squares are rational. Which are not perfect, they are irrational. Very good. Now you are learning. Now we have some properties of irrational numbers. What are the properties? So this is the first property, that see, one thing is very clear, that it is a real number. It is a real number because a real number is a part, real means irrational number is a part of real number. Okay, then first property is here that irrational numbers consist of non-terminating and non-recurring decimals. These are real numbers only. Yes, we are knowing that these are real numbers. So first two properties very clear. Then can neither terminate, neither they can repeat a set of numbers. Okay, so they are not recurring also. Okay, now one more thing is that here see this. When an irrational and a rational numbers are added, result is always irrational. Okay, if I take suppose 2 and this is rational, root 3. So what do you think? It is 2 plus 3, 5? No, it is 2 plus root 3 only. So this is an irrational number. So this is what it is saying here, properties of irrational numbers. Okay. Second thing is that when any irrational numbers multiplied by any non-zero rational number, result is again irrational. Again, no doubt. Suppose that if I multiply 2 into root 5, 1 is rational, means 2 is rational, root 5 is irrational. But the result is 2 root 5, complete irrational. So understand that rational and irrational, if they are multiplied or added or subtracted, result is always irrational. Very good. Then this is one small difference. I have tried to show you the small difference between this rational and irrational. Okay, what is that? See here. Rational numbers can be expressed in fraction, but it cannot be. Irrational cannot be expressed in fraction. All perfect squares are rational. Now, any square root which is not a perfect square is irrational. So this is how we can differentiate between rational and irrational numbers. Okay, so one thing very clear. Suppose if I write under root 3, you will say 1.732, then dot dot dot. That indicates this is an irrational number. Why? Because this is neither terminating nor recurring. Okay, this is called irrational numbers only. Okay, then we have the representation of irrational numbers. We have a representation of irrational numbers. This is our next topic of discussion. See, this is an irrational number. How it can be represented? Because the number line consists of these all values. So how I can represent an irrational number on the number line? We have to learn this. So here it starts. Suppose we have to represent under root 5 here on the number line. So what is our instruction? So stepwise I have tried to show you. The step 1 is saying that draw a number line and mark the center point as 0. This is our center point here, 0. Second step is saying that mark right side of the 0 as 1 and the left side as -1. As usual on the number line we used to do this same only. Right side is always positive, left side is always negative. Okay, then we will not consider -1 for our calculation. For our purpose, this will be not calculated. Clear? This will be not calculated. Then what is step number 4? Now there is some specific pattern that we have discussed in the classroom. Pattern is that with 2 unit as length, draw a line from one such that it's perpendicular to the line. Step 5 is that join the points O and end of the new line to 2 units length. And step 6 is that right angle triangle is constructed. How? See here. This is how we have done. From that 0, this I have taken 1 unit length and this I have taken 2 unit length. This is perpendicular also. That means this is a right angle triangle. Obviously I can use this Pythagoras. I can use that Pythagoras here. So this will become, this is here 1, this is here 2. Okay, then this will become under root 1 square plus 2 square, that is equal to root 5. Correct? This line is equal to root 5 because of Pythagoras only. How? In the next slide you see this. Here I have done. See, AC is equal to root 5. After that, now with AC as radius, see, AC as radius and C as center. Okay, this is C, this is AC as the radius. We'll draw an arc like this. It will cut the number line at some place. That only is the representation of root 5, because this is the radius of root 5, and if I'm taking this arc, so it will be like this only. Okay, so this distance and this distance is same only. Why? Because they are the radius. See now, see nicely. If I take this as the radius and if I draw a circle, it will be like this. That means this distance which is on the number line and this distance which is the radius, both are same because they are the radius of the circle. So this is root 5, then this is also root 5. So this is the concept of representation of irrational numbers on the number line. Next class we'll learn something new, some new topics we'll discuss. Till then, all of you just come in the classroom on time, be regular, it's very important, and come on time so that not a single topic should be missed by you. Okay, next class we'll learn something new. Till then, all of you take care, take your class. Thank you very much.